Hi, welcome back to the channel. In our last lesson, we saw resistors. We saw resistors in series and in parallel. In this lesson, we'll see another essential part of circuits, which is the capacitor. We use the capacitor a lot in electric circuits. They basically store energy. That said, let's get into class. Basically, the capacitor consists of two plates. Now, an electric energy is actually being applied across the two plates. When this happens, if an electric energy, say an electric energy with potential difference of V is applied and current I is actually supplied to the plates. When this happens, an electric field is actually set up between the two plates. Now, this electric field definitely has strength, and we can determine the strength of this electric field from E is equals to V over D. That means the electric field depends on V and D, where V is the voltage and D is the dielectric distance between the two plates. That is the distance between the two plates. As this current is being applied to the capacitor, charges are built up. And this charge also depends on the capacitors, on the capacitance of the material. So that C, which is the capacitance of the material, is the same thing as Q over V. Where Q is equals to IT, we say that C is equals to IT over V. With this, we can begin to see some examples relating directly to capacitors and capacitance. Our question says we should determine the potential difference across a 4 microfarad capacitor when charged with a 5 millicoulombs. Now here is my capacitor is being charged from an electric source. Here's the current I. Now the capacitor is having a capacitance of 4 microfarad. That is, the C here is equals to 4 microfarad and the Q, which is the charge, is equals to 5 millicoulombs. Now, so that my C, we say, is equals to Q over V. This implies that my V from change of subject formula is equals to Q over C. So that my V here will now be the same thing as Q, which is 5 times 10 raised to the power minus 3 over 4 times 10 raised to the power minus 6. This is the same thing as 5 divided by 4, that's 1.25 times 10 raised to the power minus 3 times 10 raised to the power 6. From indices, when we divide a negative index, it becomes positive. For you, in case you having challenges with indices, I've placed a link to our lesson here on indices. That will help you walk through it. Now, so that this now is equals to 1.25 times 10 raised to the power 3 volts. Now, let's see the second question. Our second question says, find the charge on a 50 picofarad capacitor. Now, this is a capacitor once more again, but this time around, it's a 50 picofarad capacitor. When the voltage applied to it is 2, the voltage applied to it, my voltage source, is 2 kV. So that my C, once again, we say C once again, C is equal to QV, is equal to Q over V. So that this time around, we're interested in finding the charge Q. So that Q obviously is the same thing as CV. So that Q now will be the same thing as 50 pico. Pico is 10 raised to the power minus 12 times 2 times 10 raised to the power 3. That's kilovolts. So that this is Q now will be the same thing as 2 times 50, that's 100. 10 times 10 raised to the power minus 12 times 10 raised to the power minus 3, that's times 10 raised to the power minus 9. Now, Q now, 100 is the same thing as 0.1 times 10 raised to power 3 times 10 raised to power minus 9 in coulombs. So that Q now will be the same thing as 0.1 times 10 raised to power minus 6 coulomb, which is equal to 0.1 microcoulombs. With this, I hope you understand how to attend to questions relating with capacitance and its capacitors. So let me leave you with a question which you can use, which you can practice with, and I will appreciate if you share your results with us via the comment section. Thank you for staying with us, and we'll see you in our next class.